be, Cameron? Next Tuesday. So that means the last day to turn in work from the chapter would be when, Aspen?
Next Tuesday?
Yeah.
Another question.
Yes.
Do you have Monday?
Yes, we have school Monday, and that will be our review day where we'll do the review that looks very similar to the test. Are you allowed to use those reviews, though, on your test? No, but what can you use? Your notes. So I've lately had a couple people ask on the day of the test, like, oh, can I get a copy of notes? If you need those copies of notes, you need to do that before the day of the test. I'm no longer going to allow people to get them the day of the test because part of this is to help to teach you the responsibility of, like, being prepared, right? And having things before. So I'm giving you good enough warning that you have time to get that. If you don't have it, just make sure you actually do it. And then the last thing I want to mention is about retakes for the last chapter test. So if you, because I've gotten a couple emails about it now, if you are still wanting to retake the chapter 7A test, the one that was just area, just the 2D shapes, you still can do that. You can do that tomorrow or anytime next week. Those, just remember, those have to be done before school, after school, or during lunch, and you have to have studied ahead of time, otherwise you won't do better.
I thought we're not allowed to do that for Tuesday.
I normally make it the day of the test, but just to make it a whole even week, because I don't know when I'll be available next week. Like, if I'm not available, Monday or Tuesday, then it wouldn't really be fair, so I'm just going to extend it the rest of that week. But you're right, normally it's the day of the test for retakes. For retakes. The day of the test is still the day for missing work, but if you're wanting to retake that last test, you could do that the couple days after the test. And then also I want to mention this. I don't know if I mentioned this to you guys. I don't believe I did. It's going to be, I believe, in the Bulldog Bark on Friday. Starting next week, I will always be available on Monday, every single Monday. And if I'm not, someone else will cover for me. And I will be available until 4 on Monday. So if you need additional help or you need to stay longer than the 20-30 minutes that I'm normally here, you could stay on Mondays. It is open to anybody. So if you have friends that need help with math and their teacher isn't available on Monday, they can come see me on Monday. Or if their teacher is available, but they leave at 3:15 or something, they can come here for the remainder of that time if they'd like. And then on Thursdays, Mr. Ellenboss will be available for the same thing. So if you guys needed help on Thursday and I wasn't here, you could still go see him until 4. Or if I was here, you could see me until I leave, and then once I leave, you could go over to him. So those are 2 days every single week where there will be somebody here, me on Mondays, Mr. Ellenboss on Thursdays, to help you until 4 p.m. Nikki?
So let's say if we come in on Thursday and you have 5 or 6 kids in here, could we be oh, let me check Mr. Ellenboss?
You could. It doesn't normally happen that I would have that many people on one day, but you could, theoretically. Yep. Okay. Let's get started. This is 7.7 volumes of rectangular prisms. Could I have a volunteer read the learning target for us, please? Zaid?
I can find volume in the same dimension of rectangular prisms.
Thank you. So recall that the volume of a three-dimensional figure is the measure of the amount of space that it occupies. Volume is measured in cubic units. So the surface area is if you're wrapping this in wrapping paper, you're seeing how much wrapping paper would cover the outside, right? All the different faces added up. Volume is filling up the box, seeing how much stuff you could fill up the box with on the inside. The reason it's measured in cubic units rather than square units is because we're filling it up. We're no longer seeing how many squares fit on something. We're seeing how many cubes fit inside of something. So the reason the area is squared is because it's seeing how many squares can fill up a 2D, a flat thing. Because this is filling a 3D thing, we're filling it up with little blocks or little cubes. The way we represent cubic units is like this. Units cubed with a little 3. So area is squared, but volume, since we're filling it up with little blocks or cubes, it's units cubed, units to the 3rd power. We have a formula for volume of a rectangular prism. Just I'll answer questions in a minute. Please raise your hand and wait to be called on. We have a formula for volume of a rectangular prism. So kind of like how we had formulas for area, like the area of a parallelogram is base times height. The area of a triangle is base times height divided by 2. We have a formula that helps us see how much stuff is going to fit inside a rectangular prism. This only works for rectangular prisms. It doesn't work for pyramids. It doesn't work for triangular prisms. It doesn't work for cones or spheres. It only works for something that is a box, something that is made up only of rectangles. Here is the formula. It is length times width times height, right there. I want you to circle this because that's what you need to remember. Volume equals length times width times height. I'm going to say it one more time, and then we're going to say it together. Volume equals length times width times height. Now you guys say it.
Volume equals length times width times height.
Awesome. So that means then that's what we're going to do for our rectangular prisms. Before I get to that, though, I just want to mention that a cube, this is a cube, is a special type of rectangular prism. How is what makes a cube a cube? Why is this a cube? Whereas like a tissue box or something like one of those longer tissue boxes, that's not a cube, that's a rectangular prism. What makes this a cube? What makes this a cube? Stevie? Yeah, all the different edges are the same length. That means the length, width, and height of a cube are all equal to each other. So a quicker way to find the volume of a cube is to do the side length cubed, because you know that the length, width, and height are all just going to be the exact same number. So it's like doing the same number multiplied by itself 3 times, like that. So for a cube, if it was like all the exact same, because the length, width, and height are all equal, you're just multiplying that number by itself 3 times to represent the length, width, and height. They're just all the same number since it's a cube. Okay, questions before I move on?
So
Raise your hand if you have a question. Yes.
how come you have to do like width and height?
Because volume is no longer a 2D thing and length and width are only 2D. Now we're introducing that third dimension, the height, so we're now finding the height. We need to include the height.
We were finding height last time also.
So in the last section, we did what was called base times height, but those are still just 2 dimensions, right? Base and height. That's of a 2D thing. Even though this thing is flat, we still call this measurement the height. So what I mean is that now instead of it being flat, it's going up. So we need 3 dimensions because it's a 3D object. Instead of filling the space of a flat thing, a 2D object, now I'm filling the space of a 3D object, 3 dimensions, length, width, and height. Because it's like saying, imagine you have a rectangle, and it's made up of blocks. You make a rectangle up of blocks. And that rectangle has 5 blocks this way and 4 blocks this way. That means its area is 20, right? 5 times 4. That's how many blocks are sitting flat on the table. But if I start stacking multiple rows of those, 20, 20, 20, one on top of the other, now I need to multiply it by the number of stacks I have to get the full thing, to fill up the entire thing. That's why I have height now. So I'm going to find the volume of this first rectangular prism. The first thing I'm going to do is label the length, width, and height. The length is here, the width is there, and the height is there. In multiplication, does the order change our answer, or does the order not matter for multiplying numbers? Cash? Correct. So if you labeled yours differently, your answer should still be the same because you're multiplying 3 numbers together. Because the length, width, and height could be different depending on how we twist our prism, right? If you like turn it on a different side, you're going to call something different the height. So it doesn't really matter. So now I'm going to write volume, capital V, equals my length, which was 7 over 8, times my width, which was 1 over 2, times my height, which was 5 over 8. Length times width times height. When we multiply fractions, what do we normally look for to try and like simplify them before we multiply across? What do we look for, Kieran? Cross canceling. So the thing is, with cross canceling, we normally have been working with only 2 fractions. Now we have 3. That means we're just going to have to kind of check a few more of them. So what I like to do is I like to cover up 1 fraction at a time and just compare 2 at a time. So I'm going to cover up this one. I'm going to look at these and look for cross canceling. There is none there because nothing fits evenly into 7 and 2 besides 1. Nothing fits evenly into 1 and 8 besides 1. Now I'm going to cover up a different one, and I'm going to compare the other 2. 1 and 8, nothing fits into those besides 1. Same for 5 and 2. The last one I need to cover up is the center one. Nothing fits into 7 and 8 besides 1. Nothing fits into 5 and 8 besides 1. So there is no cross canceling, but we do want to check, and because there's 3, you got to check multiple times. So now I'm just going to multiply straight across the numerator and straight across the denominator. Remember, you can use a calculator. That doesn't mean you can use a calculator to get the final answer, but you could use it to help you get the numerator and to help you get the denominator. But you can't plug in 7/8 times 1/2 times 5/8. But you could do it, use it to do 7 times 1 times 5. That's 35. And then you could also use it to do 8 times 2 times 8, which is 128. We are almost done. We just have to label our answer. Remember, we're labeling it with units cubed since we're filling this up with cubes, and since I multiplied 3 different measurements together. So I'm going to do meters cubed with a little baby 3. That is my volume. I am done. What questions do you have about example 1? Yes.
So
I'm calling on Aspen first.
what if you get like what if you accidentally put meters squared? Did you get that question? Like,
You would lose half a point because it would be the incorrect label. Nikki?
So, are we allowed to use the calculator on the test?
Yeah, if I let you use a calculator on the assignments, you will get to use it on the test. All right, moving on to the next one. This shape is not just a rectangular prism. This is a special type of rectangular prism. What type of rectangular prism is this specifically, Cameron? It's a cube because we can see how the length, width, and height are all the same. So I'm going to show you that you could do it in either way. If I want to do it like I did last time, I'm going to label my length, my width, my height. They're all the same.
Do we have to do both ways?
I want you to write what I write, just like always. The volume, capital V, equals our length, 3 over 2, times our width, 3 over 2, times our height, 3 over 2. The note I want you to write is that this could also be written as 3 over 2 cubed to the 3rd power. They mean the same thing. Just so that we're remembering in a cube, since the length, width, and height are all the same, that means we're taking that singular number, because it's the same number for each measurement, and we're multiplying it by itself 3 times. We're cubing it. Okay. Just like last time, I'm going to look for cross-canceling. But when I do that, I'm going to cover up one of them. I'm going to compare 3 halves and 3 halves. There is no cross-canceling there. I actually don't need to check any of the other ones. Why do I not need to check any of the other combos in this case? Tina? Yeah, if I cover up another one, I'm still going to be comparing the same number to itself. So there is 0 cross-canceling here. So I'm going to multiply the numerators, 3 times 3 times 3, which is 27, because 3 times 3 is 9. 9 times 3 again is 27. And then on the bottom, 2 times 2 times 2, that's 8, because 2 times 2 is 8. Or, oh my gosh, 2 times 2 is 4, and then times 2 again is 8. Again, you can use your calculator to punch in those individual things. Now, this answer I have to do something extra with. What is this answer called right now? The top is larger than the bottom. What is that called, Adriana? And I need to change it into a what instead? What do I change my improper fractions into to simplify it fully? Gavin? And can somebody tell us what this mixed number would be? Nikki?
3, 3, 8.
Correct, because 8 fits into 27 3 whole times. 8, 16, 24. But that only gets us to 24. I need 3 more to get to 8. So 3, it fits in 3 whole times. And then there's still 3 pieces, 3/8 left over. How would I label this final answer? What would I label this as? What are the units we've learned to label this with? Zaid? Inches cubed. Not squared, but cubed, since you're filling it up with cubes. Like sometimes in 5th grade, teachers literally give their students like a clear prism, and they take little cubes and they fill it up and they line them all up and they see how many fit inside. What questions do you have about example 1A or B? Okay, we are just going to do one more. In the last one, we are not going to be finding the volume. We are going to be given the volume, and we are going to use that to work backwards and find one of the missing dimensions. So one of the things, length, width, and height, one will be missing. We're going to have to find it. So it says find the height of the computer tower. That means I don't have the height, but I do have the length and the width. If you did 16 as the length and 7 as the width, that would be fine too. It doesn't matter. And I know the volume. So I know the length and the width. I don't know the height, but I do know the volume. The volume is 1,792. So the first thing I want to remember is the volume formula for a rectangular prism. Volume equals length times width times height. Now in the previous 2 examples, I replaced length, width, and height with my length, width, and height. But this time, I don't have all of those. So I'm going to replace length and width, but I can't replace height. but I can replace volume. I do know what the volume is. I don't need to write V equals again because I know what V equals. It's 1,792. So instead of writing V equals, because I already know the volume, I'm going to write the volume down, the number that the volume is instead of V. And now I am going to replace length and width. So length 7 times width 16 times height. I need to leave that as h because I don't know what the height is. So the reason this is slightly different is instead of knowing all 3 dimensions of our rectangular prism, I know 2 of the dimensions, but I happen to know what the final answer is supposed to be, what the volume is going to be. Now I am going to solve this equation. I'm going to get h by itself. But before I do, I'm going to multiply the 7 and the 16 together and see what that makes. You get to use your calculator. When you type it in, it gives you 112. Because 7 times 10 is 70, 7 times 6 is 42, 112 total. So what I'm saying is the volume, the final answer, should be the length times the width, 112, times the height. So I'm wondering, what do I need to multiply this by to get that final answer? Well, instead of trying to guess and check and add up 112s and all this stuff, we're going to use our skills from chapter 6 and solve the equation. We're going to get h all by itself. What would I do to get h all by itself? If I want that times 112 to go away, what operation will I use to undo it, to reverse it, and get h totally by itself? Cameron? Yep. We are going to divide it by 112 on both sides, like we learned in chapter 6. And Cameron is right. 1,792 divided by 112 is 16, because again, you do get to use a calculator. You wouldn't need to do that yourself. And on the other side, times 112 divided by 112, those two things undo each other, leaving only h, meaning h equals 16. Our height is 16 inches. Why am I not labeling it as inches cubed? Why did I just put inches? Bemnet? Correct. I'm finding the height, a measurement of length, which is just plain old units. The only thing that is cubed is volume. That was the volume. This isn't. This is just a measurement of the height, so it's just plain old inches. What questions do you have about this example or anything on today's set of notes at all? Kieran.
Do we always have to do the chapter 12 thing?
The chapter 6 thing of you don't have to, but it is good practice because in 7th grade, I just taught a lesson today to my 7th graders where they're using these skills again. And so it's just good practice, but you don't have to. If you wrote 1,792 divided by 112, I would give you points for that. Other questions? Okay.